Hi, this is Ayça Ergül from Bilkent University UNAM, and this video is prepared for your training sessions. First, I will go through the components of the system. There are two screens for the computer. On the desk, there is a control panel. The microscope itself is placed on a vibration desk, and next to it, there is a white light laser. There is fluorescent light source, and electricity panel is below the computer desk. Microscope itself, it has its own touch screen, and the white light laser looks like this when it is working. The black box behind the white light laser is the cooling unit. This is the microscope touch screen, and when the paint palette is selected, it opens up the light selection buttons. Fluorescent light and the IR shutter is to open the fluorescent, and the TL shutter is for lasers. Left, the buttons are for transmitted light. If you want to use the fluorescent view, you must press flow IR shutter buttons and also choose a filter such as WP or FITC. This is the controller for the stage. It moves the stage in X, Y, Z directions. The knob behind is the Z direction, and the ones in the front are for the X and Y movement. There is an option to move the stage precise or fast. We have the printed guidelines for the opening and closing of the system, which you can find next to the computer. Immersion oil is to be used for oil objectives. Here you can see the immersion oil that we use, and the microscope. The objectives are at the bottom, and light passes through the sample. When you are starting your sessions, you must first specify a folder. Here where you write your project's name and choose a folder, and always choose the autosave, and the default file type is TIFF. Laser windows are in here. Diode 405 is for UV light, and we use white light laser for everything else. Where needed, the system recommends using argon laser as well. This is how the software looks like when it is in use. There are 7 panels which I want to describe. In the first one, XYZ is the acquisition mode. There is the navigator button, and film is for fluorescence lifetime imaging, which is a unique feature of this system. SEC is for sequential scanning. In the second panel, there is the pixel and the speed selected. If you press the circle button, it gives you the optimized format. Phase X is appeared, and it's a fixed value for this microscope. Line average is that the average of the scanning will be taken, and accumulation is the cumulative one. You can choose either one of them. The numbers in between are calculated by the system. And for the Z stack, you can choose the beginning and end values, and the thickness is shown in here, and you can change the stack size. You can choose either line or frame, not both. The excitation panel shows the lasers. There are 4 active lasers, and the light path is shown with the orange line. You can choose the objective from here, you can change it from here, and also you can change the quick touch panel. And the dye assistant button is one of the most used if you're not very professional in the wavelength choosing. And here is the emission panel. The small numbers show the start and the ending of the wavelengths. And then we have different detectors. HID is the hybrid detector, and PMT is the photomultiplier tube, and TLD is the visible light or true light detector. Now let's start the system together. First of all, when you enter the room, you must log in the temperature and humidity. If it is above 25 degrees or 60% humid, you should not be using the system. We go and take a look at the opening instructions. It says to open the cooling unit. It is behind the microscope and gives out a noise. Then we open the fluorescent lamp. We open from the upper box and do not touch the lower box. The lower box is the CTR unit and it stays open all the time. Then we open the electricity panel. When we press the first button, the microscope starts working and it arranges the stage. So the stage must be empty of any samples and the objectives must have been left at the very lower level so that the stage do not hit the sample or hit the objective, and so that we can prevent the injuries to the system. Then we press the scanner power button and wait for 5 seconds. As you see, there are things that start working after pressing each of these buttons, so we do not press them hastily and wait a few seconds in between the buttons. Finally, we open the computer. Then we activate the key switch and the light turns on. The very last thing is to switch on the white light laser. The white light laser box the white light laser box is in here, and the box is vibration sensitive, so if you hit it harshly or if you put something on top of it, it affects the lasers, and the lasers then have to be calibrated or realigned. So do not put anything on this box, and if you do so, please inform the engineers. Now we open the Leica application suite and wait a little bit. Here there are some options. We choose machine and DMI8 if we are going to use the microscope. If you want to use only the computer and software and without opening the microscope, then you choose simulator SP8 and DM manual 6 and start. This may take a few moments. Now the system is opened. We go to configuration and choose memory. This is where we will specify our folder. We check that the objective is in 20x and it is dry. This is our sample, and now we approach the microscope. If you press the painter palette, we can see the fluorescence options. Now I push my hand in this opening, put my slide over there, and then push the scanner head gently backward and place the sample. Here please note that the thinner glass, which is the cover slip in this situation, must be facing the objective. So I turn it down, turn the sample down, and place the sample onto the sample holder. It doesn't fit perfectly, it is kind of flexible, so as to give the objectives some flexibility if it hits the sample, I guess. And then we put the scanner head below, and then choose fluoro and IL shutter. This we just use to find our sample. Because finding your region of interest can be the hardest thing to do in the microscopes. We use the XY knobs to move the stage in order to find our sample. And please note in this position that the objective is still very down, and there is quite a lot of spacing between the objective and the sample. Sample do not touch the objective while you move the stage. Then I put the scanner head down gently. Now I look through the binoculars. Do not, by the way, look into the laser directly. Now if you are sure you are in the right spot, now you can move the stage towards the objective. You can use the Z knob to focus your sample and look through the binoculars. You can also use the knob on the microscope. For all the microscopes, clockwise turn makes it closer to the sample, and counterclockwise makes it farther in terms of the sample and the objective. And you can check from the binoculars, and then the focus is okay. You can close the shutter and move to the computer. I press the dye assistant and this window opens. When we press the three dots, and all kinds of fluorophores open up, and then I chose the green and red calcines, and it gave three options. I chose the one with no crosstalk, and then press apply. It asks to open the white light laser, and I say yes. Here the two lasers are adjusted. For the emission, for the excitation, I have two lasers, and if SEC1 is active, then I can see where the light comes. Here in the sequential scan panel, SEC1 is selected, and then I can see the orange line coming from the first laser, and then I collect my signal in the emission panel as shown in green, and then in the SEC2 the light is coming from the second laser and then comes into the Z emission panel, which we will collect our signals. So I chose SEC1 and press live. Now at this stage I changed the fluorophore colors. This is optional. It is just for easier visualization in this part. Then I press live, and then here the first channel is black, there is no signal. This means that I should increase the laser power. If you increase the laser too much, it may cause bleaching, but I increase it, and then I can see the signal coming from the first channel. I can increase it as much as I can, but as I said, too much laser bleaches your sample. It's not very good. And in terms of confocal microscope, too much signal is not equal to better pictures. In the Sec 2, we can adjust the purple color, purple signal, and now it is obviously too much. In order to decide how much laser power is okay, I press the over under saturation button, and it opens a new colored screen. In the exposure view, the red is the optimum signal, the green means there is no signal, and blue means over saturation. So we adjust the laser power so that there are no blue areas. Whenever we see blue, we can decrease the intensity of the laser. Then I press stop because I want to adjust the format. We usually scan at 512 pixels and with a speed of 400. Then while taking a picture, we can change this, increase the pixel size. If you increase the pixel size, it means it has more resolution, but then it becomes a bit slower, so you have to adjust accordingly. If you press the saturation button again, it switches to grayscale, and if you press it one more, it returns to the selected colors. And then we have an overlay button here, which shows the merge image of the two channels. Here you can see the two colors on top of each other. Then we press stop, and then we will take a picture. There's a capture image button. It captures the image, and it is very quickly we had our picture. Then we may want to take a better picture with higher resolution, but our file is in here under open projects panel. We can increase the pixel size and lower the speed, open bidirectional X, which means that it will scan both directions, and then make the line average 3 so that it will scan 3 times and take the average for a better picture. I just made it 4. Then we press capture image again. Now it takes a bit more time to take the picture. When it is finished, it writes caption image again, and in the folder we can check our pictures. There is a metadata file. xlif is for Leica images. Here are the 2 pictures that we just took, and the second one here has this one has much finer details in it. And the first one is in here. You can see the difference. Now we can also export the pictures in TIFF files ourselves. You can put a timestamp. And a scale bar. If the overlay channels is selected, then it just saves the merged image, and if you deselect the overlay images, then it will export the channels separately. Even if you choose autosave, then still you should save the projects time to time, and it saves your files is in LIF format, is in Leica format. It is better all the time to save it time to time in case something happens. Since we have everything ready, we can kill the lights in the room and start scanning seriously. And now again I lower the adjustments to make a scanning fast scanning. And then I press navigator. It opens up a new window, and there's a spiral scan at the very bottom. If you press the spiral, then it starts from the frame that you were in, and then just makes a spiral around to see all the edges of the sample. It scans the whole area until you press stop. Here we can see our lovely plant Confocal sample. The white square shows where it is scanning exactly. Now we press stop, and it returns to the original starting position, and the white square again shows where the frame is. We can choose to change the colors and choose which one of the filters that we want to see. If we press spiral, it goes into spirals, but if you press live scan, then it just scans within the white square. So I press live and it starts scanning within the square. Now we can adjust the focus and Z position. Now there are some shapes at the bottom, and you can choose, for example, a rectangle and then select an area. You first select and then click it again just to choose that area. Now that it says that there are 8 tiles in this area, and if you press start, it will scan all of these 8 tiles. Then it just returns into the original position, and in your folder you can see that there are lots of frames, pictures of the frames separately. Now it says start, and it doesn't do anything else because we have to go to the mosaic merge section and then choose our picture, which is the last one, and then we have to press merge because there are 8 different pictures in this, and they have to be merged into one big picture. Now it looks quite nice, and then here we can choose this and export as we did before into TIFF file as a one big picture. Now, as you can see, the scale bar is much larger, 250 microns, which shows that it's a very large picture, which is a cool thing about this microscope actually, because you don't have to manually go through one frame to the other frame. It just merges into one big frame. Now in this window, in the navigator window, you can access all of the settings that you had in the previous window. If I press close and then press live, it goes to the area that we left the white square. Now you can again press this navigator, and you see that the overview scan is there. It stays there until you erase it, but I can erase this selection. It just doesn't erase the overview, but just erases the selection. And also you can save and give a name to this overlay image for further use. Now there are extra options here, like stage adjustment, and you can specify the carrier. I press close and return to our original window. Sometimes the windows look funny as it is right now, but it just normalizes itself in a minute. This is the optimized format. If you press it, it gives you the optimum measurements that you can take. You can take your picture. Now we can try Z-Stack again. We adjust our Z position with the button on the easy access panel or just in the Z knob that we used before. The easy access panel shows you the relative Z position in the slice. Now, for example, it is 35 microns, but it's a relative measurement, and you can specify the beginning and the end of the slicing sections. Now the system optimized version has 26 steps. I will change this into 15 for time restriction purposes. And then we do not press capture image because it just takes the image where the stage is at that moment, but we press start. Now it takes 15 separate pictures in the Z dimension, and when it is finished, you can see that the button returns into start, and you see nothing in here, but as if nothing, but you can navigate between the slices as shown here. Now if you press maximum projection, it puts all the 15 slices on top of each other and combines the view. But we close the max and press 3D, and it opens up in a new window. Now this is the three-dimensional view, which you can actually there are multiple options, and it goes into image processing, so it has a very powerful image processing window here. You can take slices like this, and you can see the depth of each slice, and there are virtually no limit of the different kinds of analysis you can do. You just have to allocate some time into discovering this. You can make a movie, and also there's a save image option in here for the 3D visualization. Do not forget to close the 3D viewer window because it sometimes freezes the computer before doing any further analysis. Just close it. Now we can change the objective to increase the magnification. First thing, we take our sample out before doing anything else. Then we take our immersion oil, because we will switch into an oil objective. Where we can do it is from the software, and we choose 40x wet oil, and when you're changing from dry objective to oil objective, it gives you a warning. Then it changed the objective already, by the way. Now we will put some immersion oil, just a tiny drop on top of the lens. Objective lens is okay. Again, we take our sample turn it upside down and place it on the objective. Now, because this is an oil objective, it requires the sample to touch the lens directly, to touch the oil directly, and because it is now touching the lens, there is no space between objective and the sample. You shouldn't move the stage in the X and Y direction too much. Like, you can make tiny movements, but like, you cannot search for your sample now. You have to have found your region of interest beforehand, and then now you can make very tiny movements, because you have to prevent the scratches in between, the frictions in between the sample and the lens itself. So you can just move a tiny bit in the Z direction, and if you have to move in the XY direction, just take the objective a little bit down and then move the stage. Now I checked my sample again from the binoculars, closed the shutter, and then start the live view again, because now we have increased the magnification. This saturation needs to be adjusted again. You have to, usually if you increase the magnification, you have to lower the laser power. Now it is highly saturated. Here our red channel is the second channel is has a very strong signal, and even if you decrease the laser intensity to 0.5, it still gives some exposure. So what you can do is you can decrease the gain percentage, which is the digital gain, and also you can narrow down the emission window. If you double click on the gain number, you can change it. Just by touching to the edges of the emission, how to say it, emission thingy, you can narrow it down or extend it, and also you can double click the wavelength numbers, and there you can change it. Now we return to our view, and also always look for the Z position, because if you have a thick sample, by adjusting the Z position changes the view a lot. Now I stop. To change the picture format, you cannot do it during live scanning, you have to stop it. And now I press the higher pixel size and lower speed, and increase the line average. Now if I press capture image, it takes the current picture again. It is much more slower, but here we have our picture, and you can see it has finer details when compared to the lower magnification, and actually we have a much better resolution. Now we can try zoom. You can zoom during live scanning, and when you zoom in, the movements have to be much more precise, so you can use the arrows in here to navigate your sample. And then when you find your area, you can take a picture by caption image, or everything is the same. Just that the only difference is that it doesn't allow you to go to higher resolutions while in the zoom option. Like when you increase the zoom, there is a limit to the pixel size that you can take. Now I had started the Z scan again and then opened the three-dimensional picture. I just repeated the same steps as in the lower magnification. I just wanted to show you that in higher magnification the three-dimensional scan comes into a much better shape. Here it's a temperature gradient showing the depths of the sample, so you can see some amazing pictures you can get. Also we have a true light option, which uses a photomultiplier tube detector again. It gives you true light picture without fluorescence, which you can use for your experiments. Now we come to the laser config panel and switch off the white light laser, and then we start closing our system. First we should take the sample out, and we take our sample. We take our sample, we push the scanner head back, and then take our sample carefully. We have a there is a cleaning solution for the microscope, and there is a glass sheet. The cleaning solution has some hexane and isopropanol in it, I think, and then we gently push and wipe with the cloth that we have. You have to be gentle, but you have to clean thoroughly the oil, because oil becomes very messy, so you need to be sure to clean it properly. And then we go to the knob and take the objectives down, so that we lower the level and it stays a little bit away from the stage itself. And to lower it, you have to turn the knob counterclockwise. Now we took our sample and cleaned the objective, and then from the laser configuration we turned off the laser, and we did not use argon laser. Then we can close the Leica software, Leica software. You can just close the window after you saved all your data and you are sure that you waited after you closed the lasers. Sometimes it takes 5 minutes or so to close all the system. Now in the sequence we have turn off the lasers in the supply unit with the key switch. We just turn this key and the light goes off, and then turn off the white light laser and then the computer. We come here and we close the switch. It already says laser off because we turned it off from the laser configuration, but we close the box as well. The light stays on until we close electricity panels. We can now turn off the computer, and then we can switch off the fluorescence. Again, do not touch the bottom box. Now as you see, the microscope is still active because it goes off until the electricity buttons are switched off. Now we close them again by waiting a few seconds in between. The last thing is to switch off the cooling unit. Now we check around if there is any sound coming or any thing that is still lighting, and then we finally check the room temperature and the humidity levels again and note it down. Then we can leave. Thank you for watching and good luck with your experiments.